Guys, so last week we talked about surface area of prisms. So this week we're going to talk about volume. So the first thing that we're going to start with is just a reminder. So the surface area was basically one thing I want you to add. I want you to write the word inside or outside. Sorry. Okay, so outside. So basically we had our two prisms. So our rectangular prism. Okay, so the outside, so basically the paper that it took me to create this, that would be the surface area. Same thing for the triangular prism. Okay, so the paper that it took me to make that. Now today we're going to talk about volume. This is the measure of the amount of space inside. Okay, when I'm talking about space, we can also add the word capacity. Okay. So the word capacity just refers to like how much something can hold. So even if you go into like a room, obviously our heads don't reach the top of a room, but like the capacity is how many people, like the maximum amount of people you should have in a space. This would be if I were to like glue all these edges, and then fill this with water. However much water it would need to fill, that would be my volume. Let's think of a tissue box, right? So how many tissues could I fit into this box? That would be the volume. One thing I'm not going to give you any examples of this, but I am going to show you how the volume formula is super easy, that all you need to do is know the base, the area of the base, and then how tall it is. And that actually will give you the volume of any prism or cylinder. Okay, so again, we're not going to focus on cylinders, but I will relate them to this. Now, this is what we're going to use today. Okay. And then I do want you to notice this. B represents the area of the base. So this is very important for today. Okay. Now, in the past, I have told you guys that when you guys are talking about just a regular base and height, you're always going to use lowercase letters. And today's lesson is actually why we're doing that. So this capital B stands for the area of the base. So when you guys are younger, you only do a rectangular prism. So you learn that that's length times width times height, okay? But that's just for a rectangular prism. So the reason for that is, if we think about this, volume, if you think back, is measured in cubic units of whatever sort, okay? And the reason for that is because there's 3 dimensions, okay? So surface area, again, is still just the outside of something. Now we're talking about actually filling it, so making it 3-dimensional, but then also, the actual thing that we're measuring is 3-dimensional as well. It takes up the space inside. So that requires us to know the length, the width, and the height. Now, for a triangular prism, that's a little bit different, but if we were to slide this, I tried to make this about half. So if I were to slide this triangular prism inside of my rectangular prism, 2 of them would actually fit in there, okay? And the reason for that is, think of our base. Okay, our base is 1/2 base times height, right? And this is just base times height. So 2 of these actually fit inside. So think about that when we're talking about volume. Now our examples today are going to be exactly the same questions that we did last week, but now we're just going to find the volume and now we can compare, okay? So first we're going to write our formula. And again, there's a capital B times a little h. Capital B is the area of the base. Okay. Now the nice thing about a rectangular prism is it doesn't matter. See how we have length times width times height? We already identified those. It doesn't matter how you actually, like which ones you identify as the base and the height. It's going to work every time. So we'll say 6. If this is 2, that means this is 2. So we'll say 6 times 2 will be the base. And then to make it three-dimensional, we would need that 12 for the height. Okay. So if we did those, so 6 times 2 is 12. So the volume is going to be 144. And, oh, I see a mistake I made on my last video. This is feet squared. Okay, so this is going to be feet cubed. And again, the reason for that is because we are multiplying 3 dimensions. Here we only multiplied 2 dimensions at a time and then we added them. So that's a little bit different. That's why that's still squared. Okay. Now for a triangular prism, this is exactly the same, but we have to be careful and pick the correct height for the triangle. Okay. So V equals capital B times H. So first, let's find what B is. Okay. So B is always going to be a triangle. Okay. B is our triangle base. Remember, we don't say 6 times 11 as our base because that's not technically our base. This is a triangular prism, so the triangle has to be, I don't know why I keep saying triangle. So the triangle is our base, okay? Oh, sorry guys. Okay, so when we find our triangle, the area of it, we always have to put our 1/2, okay? And then we're going to do our base, which is 6, and our height, which is 4. Now, I mentioned this last week, but you guys have to be careful when you are finding the area of a triangle. I know that there's these 5s right here, but you need that actually for the rest of it. You don't need this to find the area. You would need it maybe for perimeter, but you don't need it for the area. Okay, so our B is going to equal 1/2, so 12. Okay, so then we're going to say V equals, so BH, so 12. And then our height, remember, is this. That makes it three-dimensional. So we use our triangle to find our area, and then the height of the entire prism, 11. Okay. So then our answer, 132 yards cubed. Okay, so again, we found the area of the base. I just put a little triangle above that because it's a triangle. And then we multiply it by the height of the entire thing. Okay, so again for number 3, V equals capital BH. Okay, we'll say our base is 6 and 14 because it's on the bottom. But remember, any way you look at it, we're multiplying just those 3 dimensions. Okay. Volume of prisms are by far the easiest thing because really it's just length times width times height. But to make it easier for you guys, we give you this B, or capital B times H, because it does in fact work for every single prism and a cylinder. Okay, so we'll do another, so BH, so we're going to get our base triangle. Again, if you think back to what I said last week, when you guys are finding the area of the triangle, you're looking for the 2 sides that make your triangle a right angle, okay? And we'll talk about angles next week. You guys should have discussed right angles, but these are just two sides that create a 90 degree. Okay, so a rectangle always makes 90 degrees on all the sides. That's why we don't worry when we say base times height. There's only going to be one height. For a triangle, you have to make sure that you pick the side that, so we wouldn't use the 15, only for the perimeter, or if we're finding surface area, we would use that 15. But for the area of the base, we're just going to do 1/2 9 times 12. So the area of the base would be 54. 54. Okay. And if you want to, what I did that was easier, I said 1/2 of 12 is 6. And then 6 times 9 is 54. So then we're going to do the area of the base, which is 54. So I took it right from there. Okay. And then I'm going to multiply it by the height. So the 6 makes it three-dimensional. Remember, I say draw a triangle, and then whatever line creates it to be three-dimensional, that will be our height of the entire thing. So I'm going to multiply that by 6. And my volume is going to be 324, but this is inches cubed. Now this is crazy, guys. It doesn't always happen, but our surface area and our volume are actually the same. So very interesting to know, like, what about this made that happen? Something for you to think about. Okay, and our last mathematical example, we were talking about this garden-shaped rectangular prism. Okay, the dimensions are the length is 5, the width is 4, and the height is 2. So for this one, again, we are just multiplying the 3 dimensions together. And our volume is going to be 40. Another mistake. This one was feet squared. Sorry, guys. Okay, this is 40 feet squared. Okay, so the last thing, we're going to give some real life examples. So we'll say the amount of water it takes to fill a fish tank. Let's say, or a pool. Summer's around the corner, guys. How about the amount of tissues in a box? Okay, so the last thing we're going to do is I am going to show you for a cylinder. Okay, so again, think of like the amount of water it would take for your hydro flask. So this is just like an extension. Okay, so let's say, all right, sorry, I'm no artist, but here we have our cylinder. Okay, so I'm going to tell you that the height, let's say, is 10 inches. And the radius of the can is going to be 4 inches. Okay? So, first thing to remember, the area of a circle is pi r squared. Okay? So that's area of a circle. Okay, so if we are finding the volume, V equals capital B times H. Okay, so for the base of a circle, that is going to be pi times r squared. Okay, so that's going to equal 16 pi. Okay. So the area of the base is about 50, and I'll just write 265. Okay. Now we are going to do our volume. All right. So we'll say area of the base. We could actually use 16 pi if we want to get real approximate, or exact rather. Okay, so that's my area of the base. And then the height is just 10. So times 10. So I'm going to do 16 times pi times 10. So that equals 502. Right, 16 times 10 times pi. Okay, and we'll say 0.65, 65 hundredths, and that would be inches cubed. So again, that's just an extension. That would be like if I wanted to fill a cup with water. Cylinders are usually what I would say most cups are, or let's say like filling my mug with coffee, right? That would be your volume. All right, guys. So this week we learned about, again, volume. Okay, so think of the inside of three-dimensional object. Think of capacity. Okay, filling something up. Okay, and then if we're thinking about surface area, it's going to be the outside of a three-dimensional object. So amount it takes to, let's say, cover an object. Wrapping a present would be an example of that. Okay, so make sure you guys know the difference between volume and surface area. I will be putting a couple examples, just because volume is a little bit easier. I will be putting a couple examples on the assessment this week that will like give you some scenario. So let's say you're filling up a pool. I would ask you if that is volume or surface area. Wrapping a present, is that volume or surface area? So make sure you do know the difference between volume and surface area. And again, just one more time, the amount of paper it takes to create this three-dimensional object, that would be the surface area. Filling this with water, if I, glued these first. Filling this with water, filling it with candy, whatever you want to think, that would be the volume. Okay, thanks guys.